Okay, for question 3.2k, we have a pelican holding a fish. This is the best I could draw. Shut up. So he throws the fish for some reason. He just lets it go. And the thing is, as he's moving this way, he's moving horizontally. As the fish gets dropped, both him and the fish will both be the same position from each other. They'll be always vertically right above each other. As long as there's no air resistance, when the fish hits the water, the pelican will be directly above the fish. That's how you look at it. Now, a couple things are given to us. The horizontal distance is your code divided by 10. So mine's code is 10, but now it becomes 1.0. And the height is negative 30 meters. So this isn't drawn to scale. Like that should be a lot higher than this is, but whatever, we'll just deal with it. Now, here's our givens. We don't know what VIX is. We know AX is equal to 0 because we assume no friction. There's DX. VIY is 0 because he just drops it vertically from rest. There's gravity, and that's the vertical height. So the first question wants to know is what's the VIX right here. So we'll do this. Part A. Step number 1, VIX. Step 2, my givens are AX and DX. Once again, the only equation to use for the horizontal, 1/2 AT squared. That's equal to 0. No, I'm sorry. Let me rewrite that. This part is equal to 0. AX is equal to 0, so that gets canceled out. Step 4, this is 1.0 for me. This is equal to, that's what I'm solving for, and blank. I don't know what t is equal to. So t will be the bypass. Once again, time can be a variable that can be used on both sides. So we're going to use time to solve for, use the vertical column to solve for time. Okay, so here we go. For part B, for the bypass. Step number 1, we're solving for time. Step 2, we're going to use VIY, AY, dy. Step 3, dy is equal to VIYT plus 1/2 AYT squared. That gets canceled out because Vi is equal to 0. Negative 30 meters is equal to 1/2 times negative 9.8 t squared. T comes out to be, it is negative 30 divided by 1/2 divided by negative 9.8, the square root of it, we get that. I'm going to store that as alpha A. Right, so I have alpha A. Bring that back, and I'm just going to divide it over. So VIX is equal to 1 divided by alpha A. So 0.40. So I'm going to store this as alpha B. All right, now for the next question, wants to know if the pelican was traveling at the same speed but was only 15 meters above, how far would the fish travel horizontally before hitting the water below? So we're changing now for this question. We're going to change the dy. It's going to be changed to negative 15 as opposed to positive. So for this one, he just wants to know what dx would be with the new dy. So we have AX and VIX. Now VIX, they say, keep the same that you had from what's alpha B, and that's going to be equal to 0. So we're going to do dx is equal to VIXT plus 1/2 AXT squared. That gets canceled out. Step 4, dx is equal to alpha B times blank. Now for the bypass, we're going to be using the vertical column again to solve for time. But in this particular case, dy now is going to be negative 15 and not negative 30. That's negative 9.8. That's still 0. So we're going to use all the y's here. That's equal to 0. That's gone. So we're going to have negative 15 is equal to 1/2 times negative 9.8 t squared. T is equal to, so we're going to do negative 15 divided by 1/2 divided by negative 9.8. The square root of that. I can store that as alpha c if I want. Okay. It's alpha c. So the answer in the end is just alpha b times alpha c. So this times alpha b.